graphic organizer is just some general statements, all right, that you may see. So for example, reflexive property. We talked about that earlier this week. Remember, reflexive property just means they share a side or they share an angle. So you can set the same side congruent to itself. And why is that? Because of the reflexive property. That's why we can do that. There's also your parallel line theorem. So you can say angles are congruent or supplementary to each other because of they're either alternate interior, alternate exterior, same side interior, same side exterior, whatever. Vertical angles, you can say that they're congruent because vertical angles are congruent. You can say that these two are supplementary because they're a linear pair. There's also things like midpoint and bisectors. So we talked about an angle bisector before. So remember, an angle bisector cuts an angle in half. All right, so for example, with this one, we can say these two baby angles are congruent because that's the definition of an angle bisector. It cuts an angle in half. And then, of course, we have our lovely congruent triangle postulates, which you guys took a test on yesterday. So proving triangles are congruent, and they can be any of these postulates. So side, 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 angle, side, angle, angle, side, and hypotenuse leg. And then, of course, once we prove congruent triangles, whatever sides or angles we're proving congruent, we can say that they're congruent by CP/CTC, which just stands for congruent parts of congruent triangles are congruent. Now, I'm not going through all of these just because it's stuff we've already talked about before. I just gave that to you guys so you just have something to reference as you're doing these proofs. Because more often than not, when we're making these proofs, these are the statements and reasons you're going to be making. All right. Now, let's look at the 2.5. All right. So this packet is not the entire 2B packet. It's just for proofs because I thought that it kind of just needs to be by itself. All right. So let's start with the very first one. Now, there are two types of proofs. There's flow proofs, which you guys have actually already seen before. So do you guys remember when you had those two congruent postulate delta maths where they had like the boxes and with the arrows that they look like this? And he gave like a statement and then the reason underneath. You guys remember that from your delta maths? All right, that's a flow chart proof. And then there's also the two column proof. They're pretty much the exact same thing, just different formats. All right, still the same process. I think that either one is good in their own way. Sometimes the two column is good for the sheer fact that it's just for the sheer fact that it's more, you can see the steps. Whereas flow proofs are good because you can see where it connects. All right. Okay. So here is how proofs work. With proofs, they always give you what we call the given. All right. That's usually just something that they give us to get us started. So the given states this. Side DA is congruent to DC, and B is the midpoint of AC. All right. So my recommendation, whenever you're doing proofs, you go ahead and mark what they tell you. So side DA is congruent to DC, so that means these two sides are congruent. And it says that B is the midpoint of segment AC. So that little dot right there is a midpoint. Now, whenever you do a proof, you always state the given first. So that's why, so the first couple of proofs we're going to be doing, they already gave us the statements. We just have to state the reasons. Guys, give me 1 second. All right, so if you notice with this proof, they already gave us all the statements. We just have to give the reasons. So if you look, the very first statement is exactly what they given it. So we don't have to come up with some fancy reason why this is true. All we gotta state is, well, they gave it to us. That's it. So our reason for this would just be given. All right, those are usually like the easiest ones. So you always start with the given. All right. And again, you don't have to come up with some fancy reason. You literally just state, well, they gave it to us. It's given. Now, let's go through the rest of these statements and see if we can figure out the reasons. So I will say most of these are on that yellow graphic organizer, so use that as a reference. All right. So they then said that side AB is congruent to side BC. So they're saying that side AB is congruent to BC. Why do you think that is? What did they previously state that would make sense that these two sides are congruent? So these two little baby sides are congruent. So that's the thing about proofs. Usually a step helps you say another thing. All right, so there's something in the first step, the first statement, that told us, that leads us to the fact that A, B, and C are congruent.
Is it when they say that B is the midpoint of AC?
Right. So how this connects is that it says that B is the midpoint to AC. That's what leads us to this statement. Why? Why can we say that these two little pieces are congruent because B is the midpoint? What's true about a midpoint? Right, a midpoint's going to be halfway between a segment. So obviously, the two pieces of segments on either side of the midpoint have to be congruent. So our reason for this is that it's literally just the definition of a midpoint. All right. Now, they then said that DB is congruent to DB. Now, we've seen this one a lot. What's the reason for this one? So DB is congruent to itself. What I say is the property that you state when DB is congruent to itself, or a side is congruent to itself. What is it? It's on your sheet. What's the reason when you have two reflexive property? Good. So that's our reason. That's all we state, reflexive property. Now, the last statement is what we're trying to prove. So they asked us to prove that triangle ABD is congruent to triangle CBD. So they're trying to prove that if we're looking at this picture, this little triangle is congruent to this little triangle. That's what we're trying to prove. And if you notice, they basically stated our last statement should always be what you're trying to prove. So your last statement should always be what you're trying to prove. Now, this is where our triangle postulates come in. All right. So think back to when we did all those postulates. So side, 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 angle, 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 side, hypotenuse, leg. Based off of what we mark, that's why I say mark as you go. Based off of what we mark, what postulate do you think makes these two little triangles congruent? So what's marked? Do I have sides marked? Do I have angles marked? What's marked? We have only sides marked. What's the only postulate that deals with strictly sides? Side, side, side. And that's what they're congruent by. So literally, all we state for our last one is SSS, because that's why they're congruent. They're congruent by side, side, side. Now, for you guys, now, if this was my honors class, I would be making you guys write proofs from scratch, meaning they don't give you the statements, they don't give you the reasons. However, in this class, I'm more concerned of, can you give me the reasons? All right? Or if I gave you the reasons, can you give me the statements that go along with them? So in other words, either or. Okay? And I will say, try your best with these because you will see them again in Math 3, but with quadrilaterals. How do I know? I also teach Math 3, and I've done it before. All right? So, any questions on this first one? Okay, let's try another one. So, this time, they gave us the reasons, but they didn't give us the statements. So, we're going to be doing the opposite. All right? So, we always start by just reading what they want us to do. So it says, given that EH and FI bisect each other, we're trying to prove that triangle EGF is congruent to triangle HGI. So we're trying to prove that these two big triangles are congruent. All right. Now, the first reason states given. So what do you think I will put for the statement? We're literally just going to copy exactly what the given is. Okay? Given is usually the given statement. So we don't even have to do a lot of thinking with that one. We just copy the statement that they put up top for given. So we're going to say that EH and FI bisect each other. We're going to copy it word for word. Now, so they said that EH and FI bisect each other. So those two segments bisect each other. Now, what does a bisector mean? We already talked about this. What's bisector mean? So think about the root, bi. Typically, what does that mean? Two. All right? So what do you think a bisector does? Two lines that they intersect, but what do they do to each other? If I'm talking about two.
They cross each other.
Well, they cross each other, but that's just intersection. But a bisector does something specific. So bisector. All right, it's the same thing as an angle bisector. What did I say an angle bisector does? It's on your paper, guys. So if I have a segment bisector, so they're bisecting each other. We know it means something with two. But am I talking about just two lines, or am I talking about it doing something to a singular line? It splits it in two. All right, that's what an angle not an angle bisector. That's what a segment bisector does. Just like how an angle bisector splits an angle in half, segment bisectors split the segments in half. All right. So our next statement says that's the definition of a segment bisector? Well, we just said that segment bisectors split segments in half. So those two little pieces would be congruent, where G is kind of the midpoint. And these two little pieces would be congruent. Because again, G is kind of our midpoint. But it's a segment bisector. Wherever they cross, that means that it's a cut it into two congruent pieces. And since they bisect each other, that means they cut both of each other in half. Now, what do you think I want to put then? What statement do you think I want to make? So look at your chart. What does it say typically? If you say it's going to be definition of segment bisector, what are you typically saying? So if we look back at the chart, all right, I'm looking where it says definition of segment bisector, which is right here. What statement is typically made when you're saying definition of segment bisector? So in other words, one line segment is going to be congruent to another line segment. All right, that's what you're going to be saying. Well, if I look back at my proof, didn't I already mark some line segments congruent because of those segment bisectors? Yes, so that's exactly what we're going to say. So I'm going to say that segment EG is congruent to segment GH. Or actually, let's put that as HG. Then I'm going to put a comma because we're going to put two statements in one. What's going to be the other statement? So I got one set that's congruent. What else do I put? FG is congruent to what? IG. Good. So I said that EG and HG are congruent. FG and IG are congruent because that's what an angle bisector does. It makes two congruent lines. Now, the next reason is vertical angle theorems. We know what vertical angles are, right? Well, guess what we're going to be stating then? We're going to be stating that two angles are going to be what? What is vertical angles? Those angles are always what? Congruent. So we're probably going to be stating that two angles are congruent to each other. We just got to name them. So, which two angles on this picture would be my vertical angles? And name them in 3 letters. So, which two angles here would be the vertical angles? Can someone tell me one vertical angle? FGI is more of a line. There you go, FGE. So FGE is one of them. That'll be right here. What's the other one? HGI, or I would say IGH, just to keep everything corresponding. So we're going to say that angle FGE is congruent to angle IGH. Why? Because they're vertical. Now, the last statement is always your easiest because what did I say? So they now said that something is congruent because of SAS. Well, what's the only thing we can prove congruent using side angle side? We can only prove what shape? What's the only shape that we've been dealing with in this class? Triangles. So what do you think my last statement's going to be? I'll give you a hint. It's already on your paper technically. Right. Remember, whatever you're trying to prove, that's always going to be your last statement. So we're going to say that triangle EGF is congruent to triangle HGI. You're literally just going to copy the last statement. Now, I know that this is like, what in the wide world are we doing? So this is where, remember what I said last week about kind of, it's like you're gathering evidence for a court case. This is what proofs do. All right. We may be able to eyeball those two triangles and think that they're congruent. All right. But we actually have to list all of our evidence that leads to the fact that they are congruent. All right. So now, there's never one true way to do a proof. Sometimes you can do them in different ways, but it's all based off of what they give you initially and what they want you to prove. All right. Now, this was these two, they laid it already out for us. Okay. So let's try another one. Now, this one is they're kind of giving us a mix. So they gave us some of the statements, some of the reasons, and we got to fill in the blank for a couple of them. All right. So again, like I said, the way you start a proof, you always look at the given first. So what they state up top, you always look at what you want to prove, just so you can kind of figure out in your head, okay, where do I want to start? Well, answer is you always start with what the given is, and then use that to draw more conclusions. So always start by marking whatever's in the given. So they said that JM is parallel. Remember, that's what those two little lines mean. That means parallel to LK. So these two lines are parallel to each other. So I'm going to put the little parallel arrows there. They also said that those two same segments are congruent to each other. So I'm going to put the straight line tick on there so I can also show congruence. Now, they then stated that same statement here. So what's the reason automatically? So we just marked this statement up here, and they already stated it again here. So what's automatically the reason? Given. Easiest statement you will ever come up with. All right? Because you should always put the given statement first. Now, they then have a reason that says alternate interior angles. All right? So look on that gold sheet. If we're talking about alternate interior angles, what's our statement going to look like? So if I'm talking alternate interior angles, first off, alternate interior angles are always what? Congruent. So alternate interior angles are always congruent. So what do you think my statement's going to look like? Now, I don't really care about the angles just yet, but what do you think it's going to look like? So are we going to have segments that are congruent to each other, angles that are congruent to each other, angles that are supplementary to each other? What's it going to look like? Angles that are congruent to each other. So our statement is going to be two angles that are going to be congruent to each other. We just don't know which ones yet. Yes. Now, they said alternate interior angles. So to kind of make this a little easier, think about these lines as we typically see them, because they already said that they're parallel. All right, so if it helps, extend the lines. Now, this diagonal that they have here would be the transversal. So if I'm talking about alternate interior angles, what do I mean by that? How do I know they're alternate interior?
They're on different sides of the line.
They're on different sides of the transversal, and they're also inside the parallel lines. So, which two angles would that be? So, let's say that this is 1, 2, 3, 4. It's 2 and 3. So 2 and 3 are going to be our alternate interior angles. Now, how would I actually name them with 3 letters? All besides Luke. It'd be what? It'll be JL what? So JLK is congruent to what? So this angle is congruent to what? What's the other angle name? Not J. Remember, the vertex is always the center. So just go around a circle. LJM. So we just said that those two angles are congruent to each other because they're alternate interior angles. And I'm going to mark them just so I know. Now, they then said that JL is congruent to itself. Automatically, what's the reason? What reason do we always say if we're saying a side is congruent to itself? Reflexive property. And then our last reason is that something is congruent by side angle side. So it's the end of the proof. So what do you think I'm going to put? You're going to put triangle MJL is what? Congruent to KLJ. It's the last statement because that's what we're trying to prove. How are we feeling on proofs? I know they're a pain, but the more you do it, the better you'll get at it. But it's a lot of logical thinking, and you have to know that vocabulary. That's why I gave you that graphic organizer, so at least you have somewhere to start. Because most of the proofs that you'll do in this class will involve those types of statements and those types of reasons. All right. Okay, what I want you to do, take a couple minutes, and you can talk with your group about this. I want you to do number 4 on your own. So you can talk to your group mates if you need to.
So for the first step, give this right down together.
Remember, as you go, make sure you're marking the picture to give you a better idea of what's going on.
So that's JM. The line, right? JM. Right. JK. Okay. Then 5/6 MJK. But I think we just do a comma and just say MJK. And then we like do the side of itself. So we like do the marks like this. Oh wait, it says that JL bisects JK, so we have a comma JL.
So guys, feel free to drop your group names, not the groups alone.
Just kind of they put like a line.
Think about what the previous statement was.
For number two, I think it'd be alternate interior angles. Not sure, but I think correct. For reasons, yeah, for number two.
Oh, you're talking.
And the reflexive property would be JL is different, but JL. JL is different than JL. Yep, because that's like the
So guys, if everyone in your group is finished, compare answers.
it's a line that separates the sides.
I haven't even looked at the history. You didn't want to there, huh? I literally just went to bed this morning, so double check.
And John, I'm just gonna say this last one is like alternate exterior head. Not really sure, but that may be the answer. The last one, number 4. Yes. Yes, I think so. Well, I'm not sure if she's going to be going over it with us. So.
Alright guys, compare answers. Talk your groups, compare the answers.
That's what you got. I said that this was a given because it really says it's a given there. And it's reflexive because it's runs along like the same line and it's the same like letters in the same order. And then I said that this was alternate exterior because it's either alternate exterior or exterior, and I just went with exterior. So far, these are not as bad as I thought they'd be.
All right. Let's go through this together. So, for number 1, what did you get? Let's go with here, Luke. Right. So you just have good and right. So it says JM is congruent to JK. It also says that JL bisects angle MJK. So remember, if the reason's given, you're just repeating the given statements. So I'm just going to mark what they already said. So they said that JM and JK are congruent. And they also said that JL bisects this big angle right here. Now, some of you had issues with figuring out the reason for the second statement. Now, remember what I said. Typically, when it comes to proofs, something previously helps you state the next thing. So, what part of the previous statement do you think is going to help us figure out the reason for number 2? Anybody? JL bisects. Right. JL bisects angle MJK. Because what does it do? What does the angle bisector do? We already talked about this like 5 times today. What does an angle bisector do? It does what to the angle? Splits it in half. So, the little angles formed on either side of that line are congruent. Now, is it not true that these angles that I just marked are not the same angles that they listed here that are congruent to each other? Is that true? Yes or no? Yes. Because here is MJL and here is KJL. All right, those are the same 2 angles that they already listed for us. So, what do you think my reason will be for number 2? Let's go with Addie. So, what's the reason for number 2? Right, it's a definition of angle bisector. So, like I said, they don't just tell us certain things just for fun. They usually tell us something that would give us enough information to conclude something else. All right. Now, the next reason that they give us is reflexive. So, we know reflexive property means it's either going to be the same side or the same angle congruent to itself. So, what is the only piece of this puzzle that is true? Riley M. Right. JL is the only side that's congruent to itself. So we would say that JL is congruent to itself. So whenever you have a reflexive property, you're always just going to say that it's something congruent to itself. Now, we then come up at our last statement, which is that those two triangles are congruent to each other. So why I tell you guys to mark everything as you go is because now we can clearly see what postulate is going to tell us those two triangles are congruent. What postulate is that? Let's go, Riley E. So what postulate tells us that these two triangles are congruent? Say it one more time. Good, side angle side. Because I have two sides with an angle in between them marked. So we would just put SAS. Any questions on these proofs? All right, I want you guys to do one more on your own where you just got to put in but this time I only want you guys to put in the statements. So let's go with number 5. So take a minute and you can work with your group. They gave you all the reasons. You just got to give me the statements. So my suggestion, as you're going through, make sure you're marking on your picture. Yes.
They gave us all those statements.
You have to give the reasons.
Okay.
Yeah. So they gave us all the statements. We got to figure out the reasons. All right. So use that graphic organizer because I can guarantee you that they'll be on there. So take a minute, work with your group. Make sure you go through and mark everything as you go through because that will kind of tell you what's going on.
So, John, first one is good. I think that the second one might be equal bisector. I'm not sure, but it seems to me like it could very well be that one. Oh, I did. I'm sorry. I keep on calling you John. I know a lot of Johns, so. And so then, QPR it's not reflexive for number 3. Maybe it's right. I said that. All right, now my patient's going to think of it.
Not technically because reflexively is on the exact same. Well, think about it. So if you mark it, they were engaged. So go ahead and mark it instead.
Well, I mean, it is important to try, but it is nice that we then have the chance to have stuff.
So, first off, mark it engaged. No, parallel.
I'm gonna write assets as for last. We'll figure it out. We definitely got the first one right.
I'll give you a paper. I just got new papers for my doctor. I'm not.
So something in this statement points to this. We think part of this is now the size of well, we need to run parallel lines. So now if I can do this way, that's good.
You know what I just realized? Yeah, they just remember the steps. It's like the exact same thing as number 5. Okay, well, something in this class. So it helps. Here, like, take your point, this one. So it's on east from it's east. So that'll actually change what your statement is. Oh. All right, guys, one more minute, and then we're gonna go over it. So if you already finished, talk about it with your group. So, John, I'm sorry. So, Dylan, these are what? reasons that I gave. So I'm definitely correct. I'm not sure about the rest of these. Hopefully they're correct, but if they're not, we can leave a range of success.
Okay. Yeah. 8:15? 50. Okay. Oh, yeah, go ahead. Delta math tonight. Alrighty, let's go over this bad boy. So, as I was walking around, I was pretty proud of you guys because most of you guys did get the reasons pretty easily. So, if you use that graphic organizer to your advantage, it really, really helps when you're doing these proofs. That's why I gave it to you. Okay? So, use that resource to your advantage because there's really like, with proofs, they're so abstract. I can't tell you, like, oh, as soon as you say this, you're going to say this. As soon as you say this, you're going to say this. It doesn't work like that. With proofs, it's a lot more critical thinking and a lot more reasoning and logic. All right. It's not okay, take this number, plug it in for X, give me an answer. All right. So it's more of the abstract side of math. That's the hard part about proofs is that it's not concrete. It's pretty abstract. So what'd you get for your very first reason, Cohen? Why? Right. First statement, it's given because it's exactly what our given statement is. Now, like I said, mark as you go. Okay. So they said that NO is parallel to QR. So I'm going to use my little arrow notation to mark those. And then OP is congruent to RP. So these two sides are congruent. Now, that was a mistake that I saw. You would mark the wrong side congruent. All right. This does not mean congruent, it means parallel. That's why we use different tick marks. Okay. So arrows is parallel. Straight line ticks is congruent sides. Now, it then said that angle N is congruent to angle Q. So those two angles are congruent. What did you get as your reason, Jared? Right. So if we extended these parallel lines, all right, and for some of you, I physically turned your paper, all right? Sometimes even just changing the orientation helps you figure it out. Now, I can't change the orientation on my screen, but if you turned it to the side 90 degrees, it's a lot easier to see that those two angles are alternate interior angles. Now, that was one where, so you would say alternate interior angles are congruent in parallel lines. Or at the very least, you need to say alternate interior angles are congruent. Now, so again, that one was the one that a lot of people asked me about. Remember what I said. Excuse me. Remember what I said. When it comes to proofs, it's all chronological. So whatever they state previously, more often than not, will help you give a reason for another statement later on down the line. This is one of those. If they just say that two angles are congruent and you mark them and you're like, well, they don't look like they have a relationship to each other, check the previous statement because that may help you understand that. So in the previous statement, it was the NO is parallel to QR that helped us conclude that these two angles were congruent. Because as soon as we knew that these two lines were parallel, we can use any parallel line theorem. So alternate interior, same side interior, corresponding, whatever. All right. So just note, if they give you parallel lines somewhere in there, you're probably going to be using one of those parallel line theorems. All right. They then said that NPO, so this angle right here, I'm going to mark it with 2 ticks because it's a different angle, is congruent to QPR. So this angle right here. All right. What was the reason for that? Let's go with Ralph. So what's the reason that those 2 orange angles are congruent? Yeah, number 3. What's the reason? It's not reflexive. They're what? They're vertical angles. So we would say vertical angles are congruent. So we can't just say vertical angles. You got to say vertical angles are congruent. You got to be specific. So now we got enough information to show that those 2 triangles are congruent. All right. So what was the reason that you got for those 2 triangles to be congruent, Wendy? What postulate? Right. Angle, angle, side. So we got 2 angles and a congruent side. But if you look, that side is not the direct path between the 2 angles. So you would write AAS. Any questions on proofs? All right, so for the rest of class, you guys got about 25 minutes. There is a new Delta math. It's on proofs, but they're going to look like this. And what's nice about the Delta math is that they give you drop-down menus. So they actually drop down all the reasons. The statements are the only ones that you would have to fill in if they ask you to fill in a statement. But they also give you drop-down menus. All right. So also, what I'm also going to do is, if you guys finish this packet, so this proof packet, if you finish it and you submit those pages into Canvas, I'll give you extra credit. So if you finish this packet and you turn it in on Canvas, and I'll talk about that a little later, but I'll make a submission link on Canvas. If you turn it in on Canvas, I'll give you extra credit. I don't know what kind yet, but it'll be of some kind. Yeah. Like you guys, if you were in my math class last year, like that. So essentially, you guys, you'll just take pictures of the pages, submit them in Canvas. All right. So if you finish the packet and you submit in Canvas, and let's say by whenever our next test is, so that'll probably be in about a week. All right. Because this is also a very short unit. I'll give you extra credit of some sort. Tomorrow, maybe. Just go throw it in the box. It's the one closest to my chair. Now, guys, while you guys are getting into Delta math, just something to note. It's the one that looks older. Okay, so just something to note here, guys. All right, these flowchart proofs are pretty much the exact same thing as the 2-column that we've been doing. All right, so, but all you gotta do is give the reasons. Okay, it's just in a different format, but it's pretty much the exact same thing as what we've been doing. And again, it's nice because they give you a drop down. So you got reasons you can pick from. Now, as for the rest of these, Most of these are just either reasons or just reordering. Okay, so they give you the steps and the reasons. You just need to put them in chronological order. The only one, I gave you one problem where you actually have, oh, I don't like that one. I'm going to change this one in just a second, but I'm going to give you one problem where I want you to actually try doing a proof on your own. But I'm going to give you an easy one. I'm going to go in and change that one so it's an easy one. Okay. But the rest of these, it's mainly just either inputting reasons or filling in the blank or something of that nature. Yes. Finish them or, yeah, that's fine.